check questions, simple questions on applications of principle or moment. Okay, before we start on the question, some common understanding you need to arrive at is what we understand by what is moments, which is force times perpendicular distance. Okay, with this means student as yourself, you need to know what is the base or how to use the formulas and what are the hurdles that you are looking at when you look at this formula. Okay, like I mentioned in the video, okay, the first hurdle that you looking at is to identify the correct perpendicular distance. Okay, so it's important if you follow my three checkpoint to see how to arrive at the correct perpendicular distance. Okay, if you are still confused about it, okay, please run through my video. If I'm not wrong, should be at video 5.1. Okay, please run through that. And the second hurdle they are looking at is students need to be remember that to use the SI units when you are using the formula, especially distance. Perpendicular distance is measured in terms of meter. Okay, once you have this understanding, okay, the second one you need to look at is when we talk about equilibrium object. Equilibrium object, one of the common behavior that we are looking for is total clockwise moment is actually equal to the total anti-clockwise moment. Okay, this is the what we known as the principle of moment. Okay, so before we start the thing, you need to make sure you have these two things checked and you understand the basic application of these two concepts. Okay, with this we look at question 1. Okay, question 1, the ruler shows that it is in equilibrium. Basically, you need to be take note of this particular segment. This word equilibrium. Equilibrium, basically one of the common things that we have in terms of moment is actually saying that the total clockwise moment is actually equal to the total anti-clockwise moment. Okay, and this is the concept that we are using to solve this question. Okay, so first thing, identify the moments in the question. Okay, F2 is on the right side. Okay, it's pulling downwards. It will actually create a clockwise moment. F1 will actually create an anti-clockwise moment. So if you look at it for this question, the equilibrium question, the questions that are causing the ruler to be in equilibrium is basically these two moments. Okay, the clockwise equal anti-clockwise. So what are the forces and perpendicular distance we are talking about? So for F2, okay, this is the force that we are looking at. Okay, the perpendicular distance, same thing, measure from the line of action of the force to the pivot. Okay, and the shortest line between them. Okay, this is the perpendicular distance. So L2 will be the perpendicular distance. Likewise, if this will be the clockwise. So if it's for clockwise moment, this will be F2 multiplied by L2. Likewise for the anti-clockwise moment, okay, the anti-clockwise moment is F1, the force. And similarly, using the same testing thing, where I look at the line of action, I look at the pivot. Okay, the distance between them will be the perpendicular distance I'm interested in. So L1 would be the perpendicular distance. So for anti-clockwise moment, we are looking at F1 multiplied by L1. And because they are in equilibrium, you'll find that the two moments are actually equal to each other. So you will have the equations that you're looking for these particular equations. So all you need to do now is actually to check back with your option A, B, C, D to see which one actually give you the nearest, the exact answer for this. Okay, you will find that it's actually option C. Okay, option C is slightly different, but it's just a rearrangement of the L1 and L2. Okay, it's a multiplying. So when I bring over, it will be division. So you'll get F1 divided by L2. But actually, you bring L2 over, you'll find it's actually F2 multiplied by L2. Okay, so this option C will actually be the same representation as the one that you arrive at. So that would be the answer you're looking for. Okay. As for question 2, okay, question 2 actually is the same as question 1. Okay, the question 2 will be the same as question 1. So instead of having algebraic variables, now we actually have real numbers inside it. Okay, these two questions, I would say they are actually exactly the same in terms of concept. So all you need to do, you will find that you have F on the left side, you have 10 Newton on the right side. Okay, this will be similarly to question 1, F1. This will be F2 for question 1. Okay, so the formula you are using it will be the same. Okay, L2 perpendicular distance will be here. Okay, it's 25 cm. L1 one of the hurdle when using this formula is actually the SI unit. So L1 you need to 20 cm, you need to convert to actually meter, which is 0.2 meter. L2 will be 0.25 meter. Okay, so once you have this, you can actually substitute the necessary variables, okay, into the equations, and this will actually be something like this. Okay, so this will be F1 multiplied by F2. This will be F1 multiplied by L1. This will be F2 multiplied by L2. Okay, after that, okay, students, you can proceed on to solving the equations that you are looking. Okay, you can solve F1 to be 12.5 Newton. Okay, which is option B. Okay, similarly, question 3. Okay, question 3. Okay, question 3 is also another application or another variation of your question 1, and in fact it's question 2. Okay, so in this case your L1 will be your F1 will be 90 Newton, F2 will be your weight. So now in this case we are actually looking for F2. Okay, but the formula that we're looking for is still the same. It will be total anti-clockwise equal to total clockwise moment. Okay, same as your question 1. Oops. Question 1 I use the other way around, so let's stick to it. Okay, so let's revert to this. Okay, so question 1 I say total clockwise equal to total anti-clockwise. Okay, so now question 3 we use total clockwise to anti-clockwise. So clockwise moment. Okay, so for clockwise moment we'll find that clockwise moment is F2. Okay, so this will be F2 multiplied by L2, which is 0.30 meter. This is a moment what we known as M2. Okay, for M1, okay, this is anti-clockwise. Okay, M1, okay, it will be F1 multiplied by L1. Okay, in this case this will be your L1. Okay, so what you do is the same thing. Since they are in equilibrium, total clockwise will be equal to total anti-clockwise moment. So you will arrange the necessary clockwise moment at the correct side and anti-clockwise on the other side. Okay, so in this case, for anti-clockwise moment, you are looking for is M1 to be exact. So M1 will be here, M2 will be on the left side. So you will arrive at these particular equations. Okay, which is W, okay, multiplied by 0.3, 90, which is the magnitude for F1, multiplied by the distance, which is 0.5, and the answer you work out will be 150 Newton, which is option C. Okay, so question 1, 2, 3. Okay, and in fact later on you look at this question 4. Question 4, they are actually using only one particular concept, which is principle of moments. Okay, same thing for question 4. Okay, question 4, things to take note. Okay, the distance, necessary distance, perpendicular distance, the respective forces. Okay, and likewise if you run through question 1, question 2 and question 3, question 4, the working should be something that you will be able to understand. Okay, so please take a look at it. Okay, question 5 is somewhat different. Okay, it's different as in you will not, F2 is not given. In this case you actually need to deduce or calculate the necessary F2, okay, and the necessary L2, okay, the corresponding perpendicular distance. Okay, but the idea is still the same. The idea you are looking out for is the total anti-clockwise moment must be balanced with the clockwise moment. So when we say I need to balance, you are looking at the anti-clockwise moment must be equal to the total clockwise moment. So you need to look at option A, B and C and D. Which option actually gives you the necessary, first thing is the anti-clockwise moment, and followed by the correct magnitude. Okay, so to do that you need to first identify what is the anti-clockwise moment. Okay, the anti-clockwise moment in this case, which is 40 Newton multiplied by the distance, which is 20 cm. Please change it to 0.20 meter. Okay, and you'll find that this will be 800 Newton meter. produces a clockwise moment. Okay, so I need a clockwise moment, which is 8 Newton meter, okay, to counteract the anti-clockwise moment. So the clockwise moment, there's 8. Which of them is clockwise moment? Okay, downwards, acting on the right of the pivot. So if the pivot is in the center, 20 Newton on the right side, it actually causes it to rotate clockwise. So clockwise moment, so A possible, it gave me a clockwise moment. Upwards, 20 Newton, right side, it pushes up, the ruler will actually rotate anti-clockwise moment. So this option B doesn't give me a clockwise moment, so this will not be my option. So if you run through, so option C, okay, right side downwards, okay, 50 Newton, right side downwards, it will be a clockwise moment, so it's possible C could be my answer. Okay, and followed by 50 Newton upwards on the left of the midpoint. Now it's left side. If it's left side, I push up, okay, the ruler does, or the beam actually does rotate clockwise, so D also give me a clockwise moment. So the possible choices could be A, C, or D. So the next checkpoint that you need to look at is that the magnitude must produce the 8 Newton meter. So so option A, force times distance, please check the magnitude. Force times distance, check the magnitude. Okay, and followed by C, 50 times 10, you check the magnitude. You will find that among all these three choices, okay, only option A, okay, give me the correct magnitude, which is 20 times 0.4. I will give back a 8 Newton meter clockwise. So option A would be my answer for this, because option A has a clockwise movement, produces a clockwise movement, and is of the same magnitude as the anti-clockwise movement. So that's why for this case, I will actually choose option A as my answer. Okay. Now, before we move on, okay, please run through the first 5 questions that we have gone through. Okay, look at them and look at how I solve it, and double check if it is in line with your understanding. Okay, if it's okay, please proceed on to question 6 and subsequent few questions, question 6 and question 7. Okay, we will come back later to look at these 2 questions. Okay, please spend some time to run through the first 5 questions that we just went through.